All right, we were going to spend the last 20 or 25 minutes of how much class we had left reviewing for your quarter test. So we'll make this work in some regard here. That what the review was about was Chapter 5. Chapter 7 was so recent that I wasn't planning on doing much. Always make sure that you use your tests, your Chapter 5 test, your Chapter 7 test, and then these quizzes are the best example of what type of material is going to show up on the test. That review thing that I gave you 2 classes ago can certainly help. There's lots of good questions on it. I posted an answer key to it in Veracross as well. So, but as far as what the test is going to be like, it's going to be much more like your other test. I'll also need to let you know that because of just trying to get everything done here at the end of the quarter, I've made about 2/3 of the test, number of questions at least, are multiple choice, which many of the questions, if you go back and look at them, are multiple choice in nature, but some of them aren't, and at least on your tests. So I need y'all to just understand that there will be some Scantron versions of questions on this test, along with it, the way it is right now, which I may modify it some still. There's 50 questions, 30 are Scantron, 20 are not. All right, Chapter 5 was initially about parallelograms. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, the diagonals bisect each other, and then consecutive angles are supplementary. Those are the 5 qualities of parallelograms. What we mean by consecutive, 1 and 2, if this is a parallelogram, 1 and 2 are consecutive, 2 and 3 are consecutive, 3 and 4 are consecutive, 4 and 1 are consecutive. They're supplementary because they're same side interior angles of parallel lines. The properties of rectangles. Too many people didn't know these very well in the Chapter 5 test. There's 2 things you have to know about rectangles. Well, there's more than 2 things. Rectangles have all of these properties. Rectangles are parallelograms, plus rectangles are parallelograms that have 90-degree angles and that have congruent diagonals. The diagonals are congruent. Oh my goodness, that's so important. The qualities of rhombuses, rhombi, rhombi, all the sides are congruent. That's what makes a rhombus a rhombus. It's a parallelogram where all the sides are congruent, or it's a quadrilateral where all the sides are congruent. The diagonals are perpendicular, and the diagonals bisect the angles. Okay, those properties you have to know. So we end up seeing these questions like these. Which, hold on, this doesn't show up well enough. That's slightly better. For some reason, it's just not dark, not bright enough. But here we go. This, hopefully you can tell, is a parallelogram. Both pairs of opposite sides are parallel. But what else does this diagram give you? It gives you a right angle, which means it's a parallelogram with a right angle. That's called a rectangle. Okay, I like these questions because they help you. If you know the properties of these things, you can do it. That right there, what does it give you? It gives you one pair of parallel sides, which is called a trapezoid. Okay, one pair of parallel sides is a trapezoid. If I modify it and I make that pair of sides that's parallel, if I also make them congruent, if you have one pair of parallel sides that's parallel and congruent, that is now a parallelogram. So that is an important difference between knowing something's a parallelogram versus a trapezoid. If it's both parallel and congruent, that pair of opposite sides, it's a parallelogram. All right, look at this guy over here. All the sides are congruent. Which thing has that property? Hopefully you're telling me quickly. A rhombus. Here, this is showing the diagonals are bisecting each other into all congruent pieces. So the diagonals are congruent. What does that mean? That means it's a rectangle. All the diagonals are congruent. Now, watch how I'm going to modify both of these diagrams. I'm going to take that rhombus and that rectangle, and I'm going to make it give it both the qualities of a rhombus and a rectangle. What does that do to it? If it has the qualities of both a rhombus and a rectangle, it is now a square. A couple more. This is a parallelogram whose diagonals are perpendicular, which means it's a rhombus. Here we have a parallelogram with one pair of parallel sides that is also congruent. That is, just like the second one that we talked about up there, is a parallelogram. This one with one pair of parallel sides and another that is congruent, because it's not the same pair of parallel sides that's congruent and parallel, this would be a trapezoid, one pair of parallel sides. Actually, it's an isosceles trapezoid. One more. We have a parallelogram with a right angle in the middle. What is that called? A rhombus. There are like 3 of these on your quarter test. You can study the ones from your homeworks and your quizzes and your tests if you just need to study different versions of them. But these have just the properties of those guys. All right. Also in chapter 5, this would be a this is B here is a midpoint. You can recognize it as a midpoint with the 2 congruent segments. If I make the segment that comes from B that goes across parallel, that means that it's now a mid-segment. Okay? Mid-segments connect midpoints. So if D is a midpoint, how can you solve for X? You can set those things equal and solve for X. The other part of mid-segments is, well, what if I give you the lengths of mid-segments? So you can actually do this like similar triangles. We have smaller triangle, bigger triangle. That could work here now as well. But it's a lot simpler if you recognize that as a mid-segment. Double the length of the mid-segment is the length of the third side. So that's how you can solve that. But just remember how those mid-segment things worked. Rectangle questions have to do with the lengths of sides. The lengths of opposite sides would be congruent, and then diagonals are chopped up into congruent pieces. And we have a bunch of isosceles triangles in there. If I tell you that the measure angle 1 is 130 degrees, that means that we have 130 degrees here, we have 130 degrees here, that BEC is also 130 degrees. It's an isosceles triangle, so we can figure out what these angles are. Also, remember where all the congruent angles are. You got congruent angles all over the place, right? And isosceles triangles. So the measure angle 2, 180 minus 130 is 50, divided by 2 is 25. Then 25 degrees, we can get what measure angle 3 is a couple different ways. If that's 130, this is 50. From there we can get these angles, isosceles triangles. Or 25 degrees and these angles over here, these are going to be complementary. This angle down here is also 25 degrees, so complementary with 25 is 65. What's the measure of angle ABC? That's an angle of a rectangle, 90 degrees. Rhombuses are actually similar with respect to solving for these angles. You have the right angle in the middle, and then if I ask you about the angle measures, remember that you got the diagonals bisect the angles. So if angle 1 is 75, this angle right here is 75. The angles opposite are 75 and 75. So the measure angle 2 is 75. Measure angle 3, we have triangles. We have 90 degrees, 75, and blank. Or 75 and 75 make 150, which means that the big angles out here get 150, the others have to be 30, and then half of 30 is 15. So we can figure out those rhombus angles. Remember a question that involves the median coming from a right triangle. If you have a median, it goes from the right angle to the opposite, to the hypotenuse, to the midpoint. It creates congruent segments. Its length is half the distance of the hypotenuse, or it's equal to each of those portions of the hypotenuse. My dog's about to start barking because it can't get its ball. It's annoying the heck out of me. But anyway, if I isosceles triangles down here, it's half of a rectangle. But if you're given an angle, you should be able to figure out any of the angles. Okay, remember those types of questions. A couple more things about trapezoids. Remember that trapezoids will have 2 pairs of supplementary angles, but it's the pair. Which one is supplementary with y? Is it 140 or 120? It's 120. Why is that? Parallel line, transversal, parallel line. Remember that a non-parallel line, or at least a line, has to connect 2 parallel lines. So the transversal here is this one, y and 120, x and 140, not the other way around. If you have an isosceles trapezoid, knowing one angle helps you know all of them, because the base angles, kind of like an isosceles triangles, opposite the congruent sides are congruent angles. If this is 70 degrees here, the other base angle that's opposite it is also 70. The one that's connected by the transversal is supplementary to it, so we can get that that x is 110, it's supplementary, y is 70, it's congruent to the other base angle, and then we can, z minus 3 is also equal to 110. But just remember which ones are congruent and which ones are supplementary. And lastly, the other trapezoid thing is this. If this is a median of a trapezoid, it goes from midpoint to midpoint, kind of like the mid-segment, except we have two other sides. Double the length of the median is equal to the sum of the bases. Some people forgot to add the sum, make the sum of them. But double the median, 2 times 3x in this case equals 7x minus 10 plus 2x. I don't remember what I was doing there. But anyway, that is the process of trapezoids, and that is a Chapter 5 review. Hopefully that's a little bit helpful if you needed it. If you have many more questions, come see me. Or any more questions for that matter. Bye-bye.